This is a variation of the graphing utility you've used a couple times already in the labs. This version is especially nice for exploring the effect of transformations on graphs of functions because it will let you change some of the parameters that affect how the transformed graph looks directly from the parameter appearing in the equation that you enter. So let's enter a particular equation. Let's put in one that would correspond to the horizontal transformation. For example, let's set up one that is in terms of let's vary x squared. So instead of x squared, the horizontal transformation would be instead of f of x, it would be f of the quantity x plus c. So for x squared, it would be x plus c squared. So let's enter that. X plus c squared. Now when we hit graph, what's going to happen is that what's graphed is a particular choice for c. And if you look under this g of x, the blue curve that's graphed has the value 1 for what c is. And also what appears is at the bottom a slider. And the slider will give values, and if you change the slider, it will shift. Notice that what's happening when you shift to the right, it is giving larger values for c. And as we saw in how the graph changes, larger values for c make the graph shift to the left. So you could play with that to see the effect of that change. Let's go back and look at a vertical transformation. Let's instead put in x squared plus c. The difference there, see, is that the c that arises shows up outside. It is a change in the function value, a change in the y value, which is going to affect how the graph looks on the vertical axis. So the graph with a value c equals 1, and we can go up by moving c, the parameter, to get a larger value of c, or down to get a smaller value. We could put in a couple different parameters if we want to. F of x equals, say, x plus a. Let's put that in, that quantity squared, plus b, just to keep track of two different letters. And when I graph that, what I have now is, well, I got c still there, but it doesn't matter. C doesn't affect what this graph looks like, since c is not one of the parameters listed. But when we change b, we can move it up and down. That's the vertical shift. When we change a, we can move it left and right, and we can put in a combination of the effect of those parameters. Let's look at one that involves a multiplication. How about the syntax for the square root function is sqrt for square root. So let's do the square root of, say, something times x. So let's say a times x. Remember, you have to have the multiplication indicated with a star in the graph. So the graph only appears on the right-hand side because the square root's not defined for negative numbers. If you go from the square root of 1 times x to the square root of 2 times x, or 3 or 4, the effect of that is this vertical stretching of the graph. And a negative value shows up inside the parentheses. So if it's a negative multiplier, the only values that make sense to use to take a square root is if the total, the net sign underneath the radical is positive. So it's only for negative x that multiplying by that negative coefficient gives you something positive under the radical. So we've got that change. So I'll have a link in the this unit not only after this demonstration so that you can call up this grapher with parameters and play with it yourself. It's a useful thing to do if you'd like to go back to the old y equals mx plus b. The parameter named m is allowed particularly so that you could explore in a review session what the graph of a linear function looks like as the parameters m and b in y equals mx plus b as those parameters are